Shell Future.
All right, we're rolling. All right, so we're the Shell Future Car team. So when thinking about what we wanted to do for our alpha prototype, we were thinking back to that first demonstration we did in class with the marshmallow tower, wanting to identify what was our marshmallow in this case. We're gonna have both CAD modeling and manufacturing going on somewhat simultaneously. We chose to prototype the manufacturing today because we all have experience with CAD and with doing FEA analysis, but none of us have welded before. So that's what we're gonna talk about today.
So previous Shell Eco Marathon teams aimed to design and build the whole car, but time got the better of them. So their ideas were never actually implemented. So we decided to take a more focused approach. Due to this time constraint that we have, we decided to only focus on the bottom frame of the car, designing it and manufacturing it. And the plan is to leave enough room for the next capstone team so that they can design the top frame and the body of the car.
Sorry. So for the CAD modeling bit of this project, so we are designing the 3 sections of the frame, kind of the middle section where the seat is, the back section where most of the powertrain and the drive shaft is, and then at the front where the steering and the pedals are. So we were gonna do separate mounts for each thing and design around that and the constraints, but we saw that it wasn't really beneficial because we could have designed something that wouldn't work with another person's design. So we're more separating it into the 3 sections and dividing our work and design into those 3 sections.
So in terms of manufacturing, we looked into a bunch of different ways that we could actually connect the welds between our round pipes. The first thing that we actually did, which is on this underneath the weld that Jackson's going to talk about, was grinding down the poles to try and just fit it on there. But the second approach that we found, we looked into getting a tube notcher, but then we talked to the head of the metal shop down at the Learning Factory, and he was like, a $60 one probably isn't going to do the job as well as you think it is. So he directed us to doing milling. Milling we all need separate training for as well, so we had a TA actually mill this for us. But when you put it together, it's a pretty nice fit if you take a look at it. And basically we just need to get that training and then also do a lot more welding practice before we're ready to actually manufacture the car.
Yep, and we all are certified for welding. We have our metal shop training too, but after our first notching experiment, this is a TIG weld, and as you can see there's a hole here. The welder just melted right through the pipe, and our current was about 120 amps, and we definitely want to decrease that down to about 80 amps. And Steve, the head of the metal shop, also suggested doing half of the weld at a time to make sure our heat affected zone isn't too big. And also before welding the whole frame, just to make sure everything's in the right place, tack welding the frame as it is laid out how we want it. So we also did a tube bending experiment, and there is a tube bender down at the shop, but the only die that they had that would kind of fit this is a 0.75 diameter die, and we want a 1-inch die. And as you can see, when you use too small of a die, it really bends it too hard, and the radius is too small, so it just fails. So if we do want to bend, we have to make sure they have the right size die, and if they don't, we need to avoid rounded corners in our design. But even though we've had some problems figuring out the direction of this project, we definitely have a better idea now that we have tried manufacturing and experimenting with the CAD model workflow.
Thank you very much.
Thank you.
Any questions?
So what is the material you're using for the tubing, and how does it compare weight-wise to what's already on the car?
So this is 4130 steel. It's a chrome alloy, and steel is obviously denser than aluminum, but the aluminum frame of the current car is probably 2 or 3 times as thick as this. So if we can use this and use supports where needed, we could probably reduce the weight with reduced material and tubing.
And another key feature is weldability. So 4130 is very weldable, whereas the aluminum, that was a big challenge for the other group. So we're hoping with a bottom frame that's much more easy to modify, that it'll be a benefit for future teams.
not any more questions, then we can move on to the next